Hello everyone. In this video, we are going to discuss the solution for count zeros or pair. So let's see how we can do this. Now, what the question says is that we need to count zeros or pairs. So first of all, what we have been given in this question is an array of size n. Let's take this array that we have been given in our sample input, right? And what we need to do is find the number of pairs such that ai or aj equal to 0. So uh, the best solution for this that anyone can see is that simply make all the possible pair and see if their XOR is 0 or not. And if their XOR is 0, then simply increase the number of pairs that we need to return, right? So let's do this. First we will start from this first index or zero index. Let's try the index 0 1 2 3 4 5 zero index. Now this one is going to be paired with this, then this, and now after pairing with everyone, now this one is going to make pair with this. Likewise, all the numbers are going to make pair with each other. And if I will try to come up with the solution with this kind of approach, this is going to take a long time. It will take somewhere around n square time of n square, because each time I'm trying to create a pair. I'm actually calculating all the pairs, then I'm checking if this dot gives me 0 or not. But I think that should not be our solution, because it's going to take a very long time to calculate if we have many more number than this. Okay, so we have been already given that our XOR's value should be 0. So let's try to find the scenario in which our ai XOR aj is 0. So this is my array. Tell me what kind of possible pairing should are present. It will be 1 3 1 1 1 and 3 3. So let's try to dot them, because every other possible combination is going to be made from these two. Okay, so 1 is 0 0 1, 3 is 0 1 1. Dot them 0 1 0 1. Yeah, again 1. We sort them 0 0 0 3, which is 1 1 1 1. Sort them, we get 0. Did you see something? Yeah. When we have 1 1, we got 0 0. We have 3 3, we again got 0 0. Isn't this what we needed? AI is or aj equal to 0. So if you have remembered the bit manipulation part from our earlier in the course, you will understand that this is what we are doing. The XOR of same number will give me 0. So if I know how many times this same number is occurring, then only I can pair with them. And if I pair with them, then this means my XOR will be 0. So 1 is going to be paired with 1, 3 is going to be paired with 3 to give to have the XOR 0, right? So I have 4 times 1 and 3 times 2 times 3. Okay, so let's make the pairings. This is my first one. First one is going to make pair with second, then third, and then fourth. So first one is going to give me 3 pairs. Now And for the second one, this is going to pair with third one, then the fourth one. Second one is going to give me three pairs. Oh, sorry, two pairs. And my last one is going to pair with fourth one. Third one is going to pair with fourth one. Right. Now this gives me one pair. Also, these two three is also going to give me one pair. So all if I add all the pairs, I will get 7. Hmm. This result is not showing me any possible insight for the solution that I am going to make. But can you see something here? Only this part. 3, 2, 1. And here, how many 4s are there? 4. 4 number of 4s are present. Let's use darker one. Right. I have 4 4s, and this is what I'm getting for the number of pairs. If you are able to see some pattern here, it's well and good. If we are not seeing the pattern still now, I suggest you to pause this video right now and try to figure it out. Okay, so I think you have tried to think and you have found that if I have 4 number of ones present, then this is nothing but sum of 4 minus 3 4 minus 3 sum of natural numbers 3, 2 and 1. Right. So if I'm able to find all the frequency of the numbers that is present in my array and try to find their frequency minus one's natural sum of natural numbers, then I'm able to get the frequency for each of the number. Sorry, possible pairing for each of the number that can give me XOR aj equal to 0. Right. So let's take one more example. I have a blank array here. Let's say I have 1, 1, 2, 2, 3, 3. So I have this array and I need to find how many pair are going to give me XOR equal to 0. Okay, this is very small array. Let's make it a little big. 2, 2, 5, 5, 1 and 1. Right. This should be my array and I'm going to use hash map. So let's use it. Let's go from this point to this point and try to find what can be what are we going to see. So here's my hash map. Okay, so let's start from this. I got 1, hash map was empty, so I added 1 and it is occurring 1 time, so its frequency is 1. I found 1 again, so I'm going to increase the frequency. I found 2. 2 is not present in hash map, so I will add 2 and say its frequency is 1. I found 2 again, so I will increase the frequency of 2. I found 3. 3 wasn't present in my hash map, so 3. And what I'm going to do, I'm going to increase the frequency to 1. I got 3 again, so frequency of 3 will be increased to 2. Now I have 2 again, so I'm going to increase the frequency to 3. Okay, I've got 2 again. Now frequency will be increased to 4. I've got 5. 5 wasn't present in my hash map, so I will add 5 and it occurred 1 time, so frequency is 1 now. Now 5 occur again, its frequency will be increased to 2. I got 1 again, frequency will increase to 3. I got 1 again, so my frequency will increase to 4. Now 1 has occurred 4 times, 2 has occurred 4 times, 3 has occurred 2 times, 5 has occurred 2 times. Okay, this is the frequency for all the possible numbers. Now we will try to get the sum of n natural numbers. So 3 plus 2 plus 1 for this, 3 plus 2 plus 1 for this, and 2 plus 1 for not 2, 1 for this and 1 for this again. This gives me 6 into 2 because there 2 times 4 is occurring, so 12, and this is going to give me 2. So 14 possible pairs are there, which is going to give me XOR of 0. Now I have calculated 14 very easily, even without using that naive solution, which was trying to pair everything with everything. I just needed to do what I needed to do. I need to get all the unique values and see their frequencies. That's what I have done here, and then just calculated frequency minus 1, sum of frequency minus 1 natural numbers. That's it. That's what I have done, and I have found 14 pairs are present, which are going to give me what? XOR 0. XOR result 0. Okay, so I think we are done with the solution approach. Now what we are going to do, we are just going to code this. Now it's very simple. It's not going to take much time now. Alright, so let's see how we can do this. So first of all, what we need is a hash map. So I have already included an ordered map here. So let's create a hash map, int for storing my key values and int to storing the frequency. Alright, okay, so let's name it hm equals not equals, just that, and we have created a hash map. Now I need to travel over my array, int I equal to 0, I less than arr dot size, or yep, and I plus plus. Now what I need to do is I need to see if the key is contained in my hash map or not. If my key is already in the hash map, then what I need to do is increase its frequency. Okay, so let's do this. If hm dot find, if I'm able to find the element, meaning the key, in what, in my hash map, hm dot end, meaning my find iterator does not go to the end, it is able to find the key. So what I'm going to do, I'm going to increase my frequency that is stored in my hash map. So hm arr I plus equals not hm, just 1, because I have found my key at 1, key with once. Okay, else if I'm not able to find it, it means that current element is not in the hash map and I need to create a key for this. So hm dot insert, what I'm going to insert, a key value pair. Key is going to be key is going to be my array element. So make pair of key, which is nothing but ARR of I, and frequency. So I have found this first time, so I'm going to say that this is the first time this is occurring. So frequency should be 1. So I have inserted in the pair. All right. Now what I needed to do, I needed to calculate the pair. So pair here it is, but to travel a hash map, I need a key set pair. So for this, I need a iterator. So let's copy paste this and create a iterator for this hash map. And I'm creating iterator. Iterator, let's name it ITR. All right. Now for ITR equals hm dot begin and ITR not equal to hm dot end, meaning that my data is going to go over my entire hash map. So that's it. I plus, not I plus plus, it should be ITR plus plus, and that's it. Now what we need to do, we need to check the frequency, and according to that we were doing something. So in the hash map what we have stored was frequency. So let's now name it frequency FREQ, and I was using iterator, so ITR. And where is the value of frequency kept for a key? In the second part. Yeah, you can see that I have used second part of it as the key. All right, so second SECOND second. Now I need to add, what I'm going to add is some frequency minus 1 natural numbers sum. So for this simple formula, FREQ minus 1 star FREQ divided by 2. Now don't ask me where this formula came from. This is formula for calculating n number of what? Sum of natural numbers. Okay, and natural numbers sum is given by this formula. No, not n minus, not n, but n minus 1. Okay, so if you want to find more about it, go and Google it, because I'm not going to tell you how we reach this formula. So that's it. Now what we need to do, we need to just return this pair. All right, so let's run it. Okay, all right, I forgot the brackets, so it's been accepted for my sample test case. Submit it, and it passed all the test cases. Now, as I said earlier, I'm going to tell you about the time complexity and the space complexity later on. So let me fulfill that promise. All right, so it's working. Okay, now tell me how much time this for loop is going to take. This is iterating over my array, so it's taking some n time. And this iterator for hash map is iterating over the hash map, which is also going to take some n time. So doesn't this make the time complexity for this function O of n? Yeah, n. Now n is always less than n square. So this is much more efficient uh, than the approach that I have told you the first time, the naive algorithm, which was try to make all the pairs and then see if their door is 0 or not, and if their If this or was 0, then what we are going to do, we are going to increase the number of pairs. So this is much more efficient. Okay, in terms of time it is. But if you look carefully, we have created a hash map, right? So hash map is going to take some space, which will be O of n, because at max we are, what we are doing, we were inserting here. So at max it can take n values, so space complexity is n, whereas when I was telling you about the naive solution, it's space complexity was constant. I wasn't using anything there, but as I'm using hash map here, the space complexity should be O of n. So that's all for this solution, and I have told you about time complexity and space complexity for this function. Alright. So that's all for the solution of the program. I would suggest you to go back and try this solution once again on your own, and good luck with that. With this, I wish you luck, and that's all for this video. See you in the next question.